All right, here's the rest of the problems. Numbers 12 and 13, we're deciding if the angles are complementary or supplementary. So those are two definitions that you're going to need to remember. Complementary angles are two angles that add to 90 degrees. Supplementary angles are two angles that add to 180 degrees. So if you look at 12, if we take 53 plus 127, that's 180. So these angles would be supplementary angles. Now, 13. 42 plus 48, that's 90 degrees. So these two angles would be complementary angles. Another way we can see supplementary angles, if we have adjacent supplementary angles, it would look like this. We know that these angles, even if it doesn't say what the measure of those two separate angles are, because they form a line, that means they form 180 degrees together. So we would say that those are supplementary angles. And with complementary angles, if we have a 90-degree angle that is divided in two, even if not evenly, if it doesn't tell us what these two individual angles are, we know together they add to 90 degrees, so those would also be complementary angles. All right, on number 14, we are finding the value of x, but we're also classifying the triangle. So let's start with finding the value of x. The angles of a triangle, if you remember, they all three of them have to add up to 180 degrees. Every triangle, the three angles add up to 180 degrees. So we know that if I take x plus 35 plus 35, it needs to be 180 degrees. Well, 35 and 35, that makes 70. So if x plus 70 equals 180 degrees, that means I have 110 degrees left over for x. So that x equals 110 degrees. Now, the second part, we have to classify the triangle. We classify a triangle two ways. You need two words here. One by the angles and two by the side lengths. So first, we ask ourselves, is there a right angle? Is there an obtuse angle? Or are they all acute angles? We just found that x is 110 degrees. So that means that this angle up here is obtuse. So this is an obtuse triangle. If there was a right angle, it would be a right triangle. If there are no right angles and no obtuse angles, it would be an acute triangle. All right, so it's obtuse. Now we also have to classify it based on the sides. These little marks, remember, mean that those two side lengths are the same. This one does not have the same mark. So not all of the sides are the same, so it cannot be equilateral because not all the sides are the same. Equilateral means all of them are the same. Just two are the same, so it is isosceles. And if none of them are the same, that's scalene. All right, now I made a whoopsie on 15. There is actually no x to solve for here. All the angles are known. We have a 30-degree angle, a 60-degree angle, and a 90-degree angle, and they all add to 180, just like they're supposed to. But we can classify this angle, so we classify it two ways. One by the angle measures and one by the side lengths. So the angle measures, we know one of the angles is 90 degrees, so this is a right triangle. Now for side lengths, it does not show us that any of these sides are the same length. And if none of the sides are the same length, that's called scalene. So this is a right scalene triangle. All right, now let's talk about quadrilaterals. Okay, think about our little quadrilateral family tree that we made. There are three types of quadrilaterals. There are those that don't have any parallel sides, those that have one parallel side, and those that have two pairs of parallel sides. If there's two pairs of parallel sides, so tops are parallel, sides are parallel, then that's called a parallelogram. And then there are multiple types of parallelograms. If there's only one set of parallel side, it's a trapezoid, and that's the only one you have to remember if there's one pair. And if there's no pairs of parallel sides, sometimes it's a plain old quadrilateral, but sometimes it's a kite. And if it's a kite, it's because we have two pairs of congruent sides. You guys know what a kite looks like. So let's look at the top one. These arrows mean that the sides are parallel. So there's one pair of parallel sides, which makes this one a trapezoid. All right, now let's look at the bottom one. Now looking at them, it looks like the side, we have two pairs of parallel sides here. It doesn't say that, but it looks that way. So we would have a parallelogram. Then from parallelogram, it could be a rhombus, it could be a rectangle, or it could be a square. Well, all the sides are the same length. but none of the angles are the same. So it can't be a square because it doesn't have a 90-degree angle. So this one's a rhombus. All right, and lastly, 18, you did not have to classify this one. It's just a plain old quadrilateral. There are no pairs of parallel sides, and it's not a kite, so it's nothing special, just a plain old quadrilateral. But you had to find the missing angle, the missing x. And we talked about triangles. All three angles add up to 180 degrees, but for a quadrilateral, the four angles add up to 360. And the reason why is if we divided a quadrilateral into two triangles, we have 180 degrees in this triangle and 180 degrees in that triangle, which makes 360. Okay, so all four of those angles have to add up to 360 degrees. Well, we have 90 degrees, we have 130 degrees, and we have 75 degrees. Okay, so let's add those together. 90 and 130, that's going to make 220. And then plus 75, so now we have 295. But we wanted all of our angles to add up to 360, so we have to ask ourselves what's left for x. So 360 minus 295 is 65 degrees. All right, last two problems about scale factors. This one's talking about a map. It tells us that 0.5 inches on the map is 20 miles in real life. So we would set up our first ratio as 0.5 inches to 20 miles. And then the distance between the two cities is on the map is 6 inches. So inches and inches. So the top is for our scale. The bottom is for actuality, how far apart the cities actually are. So we want to find how far apart they are if they are 6 inches apart on the map. Now, you can use logic to solve this problem. So 0.5 inches, for every 0.5 inches, there are 20 miles. So let's think through this. How many half inches can we put together to get 6 inches? 12. So since it takes 12 half-inch segments to get to 6 inches, then we would take 20, that's 20 miles for each one, so 20 plus 20 plus 20 plus 20, 12 times, or 20 times 12, 20 times 12. So if you take 12 times 20, we get 240 miles. Now, if you don't like logic and you like a straight and narrow way to do things, we can also set up a proportion here. So this is a proportion. Now we can cross multiply our proportion. And to cross multiply, we would take 20 times 6 equals 0.5 times x, or 1/2 x. So we have 120 equals half of x. So half of what number is 120? And that's another way to get 240 miles. All right, now 20. This one's a little bit different than the last one we just did. So this one, it says, a scale drawing of a painting is 12 inches long and 8 inches tall. So I'm just going to use that scale. So 12 inches long, so I'll put a little long there to remind myself, and 8 inches tall. So tall is like your height. So I'll do length and height. The actual painting is 3 feet long. So 3 feet long, 12 inches long. So I want the 3 feet to go with the 12 inches. Because if I put it on bottom, that's talking about the height, because 8 inches was talking about the height. But it wants to know the actual height of the painting. That's the first part you had to find. So let's see. Again, you can set up and cross multiply here. We can take 8 times 3 equals 12 times x. So 24 equals 12x. So x equals 2 feet. That's one way to do it. Another way to do it is if this length is 12 inches, that's 1 foot, and it's 3 feet in real life. So in real life, it's 3 times as big as it is in the scale. So if the height is 8 inches, 3 times that is 24 inches. And 24 inches is 2 feet. So that's another way to think about it. Again, multiple different ways to get to the same answer. All right, so then we spice it up a little bit more. Now, if you know the height, and you know the length, then we can find perimeter and area. Remember, perimeter means the distance around. So first we're finding the area in perimeter of the scale drawing. So that's the smaller one. So that's the 12 inches and 8 inches. So it's 12 inches long, 8 inches tall. So let's draw a rectangle. Maybe that'll help. So 12 long, 8 tall. All right, so if I were to do the perimeter, so all the way around, we're taking 12 plus 8 plus 12 plus 8. And that is 40 inches. Or you can convert that to feet. So let's see, that would be 3 feet and 4 inches. All right, now, area of the scale drawing. So area, we take, it's a rectangle, so length times height, or base times width, I think you also do, length times width, whatever. So base times height, length times width, that's what it is. Okay, so we've got 12 times 8. 12 times 8 is 96. Because it's area, we square our units. All right, now, last one. We need to find the perimeter and area of the actual painting. So we found out our actual painting is 3 feet long and 2 feet tall. So if we draw a little picture, 3 feet long, 2 feet tall. All right, so perimeter, we're going 3 by 2 by 3 by 2. So add all those together, we get 10 feet. So a lot bigger than our 40 inches. Now area, we take 2 times 3, and we get 6 feet squared. And that's all. Good luck.